The distance s an object falls is directly proportional to the square of the time t of the fall. If an object falls 16 feet in 1 second, how far will it fall in 3 seconds? And then another question, how long will it take the object to fall 64 feet? Recognize that we have the keyword directly. We're looking at directly proportional. And in this particular case, they're giving us the variables that we want to use, s and t. And it's actually saying the square of the time t. So we want to square that t. It's easy to overlook words like that, like the square of the time, or it might say the cube or the square root. Always look for those extra keywords to know what we need to do to those variables. Next, we're going to plug in some given information to find k. We're told that an object falls 16 feet in 1 second. So the distance is 16. K, we don't know, that's what we're looking for. Time is 1 second. 1 squared is just 1, so we get that k is equal to 16. Now we'll plug that back into the original equation. S is equal to 16 t squared. Now let's attack the first question. How far will the object fall in 3 seconds? S is equal to 16 times 3 squared. S is equal to 16 times 9. And then 16 times 9 is 144. And in this case, we're talking about feet. So the object will fall 144 feet in 3 seconds. Notice we also had a second question. So we'll go back to the equation with our k value of 16. This time it's asking how long will it take for the object to fall 64 feet. So we have 64 for s, the distance, equals 16 t squared. Divide by 16 on both sides, and we get 4 equals t squared. Then we want to take the square root of both sides, and we get t equals plus or minus 2. Whenever you take the square root of both sides, typically we do plus or minus, but in this case, we're only going with the positive version of time, so 2 seconds. Be careful with questions like this that actually have 2 questions built into it. Sometimes it's easy to overlook the second question.